Hello, how are you? In this video, I'll review the entrance exam study guide for the Division of Basic Sciences and Engineering at the Metropolitan Autonomous University. As you can see, I have the guide here, and I'm going to go all the way to page 25, I think, because here we have look. Here we have a self-assessment, and I'm going to explain to you how to solve each of the exercises in the self-assessment. But obviously, only the ones that have to do with mathematics or mathematical reasoning, look here. I think it was to be expected. We're going to have more questions from the mathematics section. After all, we're in a basic sciences and engineering exam, so it was to be expected, right? From question number 13 to question 82 or 83, they're all math questions. So what I'm going to do is put blocks of 10 exercises in each one so that you can please see them in order. Let's start with exercise number 13. And to make it easier, I'm going to share this other screen with you, where I've already put each of the exercises so we can solve them little by little, slowly. Okay, come on, let's go with exercise number 13, which says, a rectangular window is L meters wide and H meters high, with a perimeter of 6 meters and an area of 2 square meters. Which of the following? Which equations can be used? Sorry, with which of the following equations can you calculate the width of the window? Let's see. I'm going to start by drawing my window here. Don't pay too much attention to my rectangle. It's going to look a little ugly, but there it is. Look, there it is, more or less here. So we have the window, and we know it's L meters wide and H meters tall. Also, they're telling us that the perimeter of the window is 6 meters and the area of the window is 2 square meters. That's all we know, right? I'll be doing the work in green. Let's see. Let's first set up an equation for the perimeter. We already know that the perimeter is simply adding up the lengths of each side of our rectangle, right? So, for the perimeter, which says it's 6, we're just going to write the number itself without the units. So the perimeter would have to be equal to L plus H plus L plus H, right? In this case, then I would have 2 times L plus 2 times H, so that would be the perimeter, which means it has to be equal to 6. Would you agree with me that here I can immediately divide both the left and right sides of the equation by 2? If we divide by 2, then here I would have 2L divided by 2 that's equal to L, plus 2H divided by 2 is equal to H, and this is equal to 6 divided by 2, which is 3. All right, now we already have a little equation that will help us. Now let me set up another one. This one will be with the area, right? We already know that the area of a rectangle is calculated by multiplying the length of the base by the height. In this case, then I would have that L times H has to be equal to 2 square meters. Right? In this case, I'm just going to write the 2. And here we have another equation, right? We're going to need this one too. Now it's important that you pay close attention here. Look at the question. It says, with which of the following equations can you calculate the width of the window? Is the width shown as L? So what we have to do is leave an equation, but it should only be in terms of L, since I want it in terms of L. So I need to solve for H, right? All right, let's solve for H. So H equals what? We'll divide by L to move it to the other side. So it would be 2 divided by L, that's what H is in terms of L. So we can plug it directly in here, right? Let me continue over here then, down below. So I have L plus, here I go to H, but H is 2 divided by L. So we put 2 over L, and this has to be equal to 3. Right? Ready? Here, it's convenient to multiply both sides of the equation by L. So, let me go ahead and write here that I'm going to multiply by L. So let's continue. The reason I'm going to multiply by L is so I don't have a fraction here. Okay, so let's go. We multiply L by L. I get L squared plus L times 2. That's 2L over L. So I'm just left with the 2. And on the right side, we have 3 times L, which is 3L. We're doing well so far, right? Okay, so now we're just going to move this 3L to the left side. So I'll have L squared minus 3L plus 2, right? This now equals 0. There's nothing left on the right, so we put a 0 done. This equation is the one I can use to calculate the width of the window. L squared minus 3L plus 2 equals 0. And which one is that? That's the quadratic, right? L squared minus 3L plus 2 equals 0. I've printed the answer sheet, so let's check if I got it right. The answer to exercise 13 is A. So we got it right. Now let's move on to exercise number 14. Let me click here. Done. Here we have the next exercise, which says, X grams of pure silver are melted with 200 grams of an alloy that contains 75% of this metal. That is, pure silver, right? Identify the equation that allows you to calculate the X grams of pure silver so that the new alloy contains 90% silver. Well, first of all, I have to tell you that this problem might seem a little complicated at first because it has some information that, well, could be confusing. But the truth is, it's actually pretty simple. The first thing we're going to do is calculate how many grams of pure silver are in the alloy, because it says X grams are melted. So up to this point, X grams of pure silver. With what? With. Actually, there are 200 grams of an alloy that contains 75% of that metal, meaning pure silver. So the first thing I'm going to do is multiply these 200 grams by what? Well, by 0.75. So I can find out how many grams are pure silver in that alloy, right? Okay, let's do the multiplication. This one's simple, right? Because we have 200 times 0.75. It's like having 75 times 2, right? That's 150. It's important for you to know that we're going to do all the calculations completely by hand, okay? We won't need a calculator at all. All right. So what I have left here is 150 grams of pure silver, right? That's because we had an alloy, right? So from these 200 grams, right? That's where it comes from. So, out of those 200 grams in the alloy, 150 grams are pure silver, right? All right, so the question is, identify the equation that allows you to calculate the X grams of pure silver so that the new alloy contains 90% pure silver. How are we going to do it? Well, we would have to do a division, right? We would have to calculate the amount of grams of pure silver. Divided by what? So, divided by the total grams? Now, how many grams of pure silver do we have in total? Well, we have these X grams. I'm going to add X plus. Who? Well, plus these 150 grams, right? These 150 grams, remember, come from those 200 grams that the alloy had. First, we need to divide by the total grams. So what is the total number of grams? It must be the X grams of pure silver. Plus what else? The 200 grams that the alloy has. Do we agree? Look, this is just pure silver, and this over here is pure silver, plus the other 200 grams that the alloy had. This has to be equal to, what do you think it should be here? You can even help yourselves a bit. What should it be equal to? 0.9 or 90? Well, it has to be equal to 0.9. Why is that? Because remember that when we express percentages, we don't put it here as equal to 90%, right? I mean, think about it. It wouldn't make sense for this to give us 90y? No, because what we're really doing is finding a decimal value, right? So here we would have to put 0.9, and that's it. That would be the answer. Nothing else, right? So which one is it then? It's X plus 150 over X plus 200, just written differently, equal to 0.9. So, is it option A? Notice the others look similar, but we can dismiss some since they don't make sense. The correct answer is A. That's it. And actually, in the exam here, let's see question number 14. It says it's A. So we got it right. Okay, look, this doesn't make sense. Because for example, 200 plus X, what would that represent? Well, that would be the total grams, not just the pure silver ones. So, 75 plus X doesn't make sense. Why? Because 75 is the percentage of pure silver in the alloy. So, this one shouldn't go here. And neither should this one since it's the same. This one could work, as could the one in the denominator. The problem is that here it's set equal to 90, But it doesn't have to be equal to 90, remember, because here we're actually calculating a decimal, right? And when we interpret that decimal, we already know that 9 represents 90%. Okay, so that's it. The correct answer is option A. Let's go to exercise number 15, which says, in a right triangle, one of the acute angles is 10 degrees greater than 3 times the other. Determine the measure of the larger one. Okay, so let's see. We have a right triangle. Let me draw it so we can start adding some data. We don't know the other angle's measures, so let's use a variable for now. Since it's a right triangle, this angle is 90 degrees. That's all we know, right? We know one of the two left is bigger than the other. I'm going to say this angle is alpha and this angle is beta. Okay, so the smaller one is alpha and the larger one is beta. We'll need to set it up with that information. In a right triangle, one angle is acute, right? It's 10 degrees greater than 3 times the other one, okay? So, which one should be bigger? Well, this one, right? So beta has to be 10 degrees greater. So I'll write 10 plus what else? Triple the other one. In this case, triple alpha. So triple alpha means triple the other one. I added 10. I add 10, so I get the other angle, which in this case is angle beta, and that's it. So now we have our equation here. What else can we know from here? Well, we can know that the sum of alpha plus beta plus 90 is 180, right? Or in other words, alpha and beta have to add up to 90, right? I'll put it better this way. So let's say that alpha plus beta equals 90 degrees, okay? I'm not going to write degrees, but we know there have to be degrees here, right? Everything is in degrees, so let's leave it. They're asking me to determine the measure of the larger one, so in this case, that's beta, right? So, in order to find the value of beta, I could solve for alpha from here, right? So let's do that. We solve for alpha, and we get that alpha equals 90 minus beta. I can substitute this now, right? I'll do it. So, here we get that beta equals 10 plus 3 times alpha, but alpha is 90 minus beta. There we go, right? Let me continue down here, so I'm going to keep going this way. Sorry for making such a mess, but I just want to optimize the space. So I have that beta equals what? Well, 10 plus 3 times 90, so that would be 3 times 9, 27. And that's it, I just add a 0. And plus 3 times minus beta, so I get minus 3 beta. This minus 3 beta. I can move it to the other side, so I have beta. Plus 3 beta. And on the right side, we have 10 plus 270, which is 280. We add the betas. Beta plus 3 beta is 4 beta. And on the right side, we still have 280. Now we solve for beta from here. So we're going to say that beta equals 280 divided by 4. That's 7 times 4, which is 28. So 70, right? So beta, now I can add the degrees. Beta is, or measures, 70 degrees. So the correct answer is option D. Let's verify exercise 15 option D. Correct. We got it right. It's simple, right? They're getting a bit more complicated, right? Let's continue to exercise 16, which says, a pool can be filled in 7 hours when 2 faucets, A and B, are used at the same time. When only one of these 2 is used to fill the pool. Faucet B, takes half the time that faucet A needs. In how many hours does faucet A fill the pool? Let's see. It might seem a little complicated, but it's really not that much, okay? Look. I can do this one quickly using logic, and then I'll do it with a slightly more analytical process, but with logic, it's super fast. Let me draw the little picture. In this case, I'm going to draw my pool a bit round, like a cylinder, for practical reasons. But really, it's supposed to be a pool, so it should be rectangular. But I'm going to do it this way because I want you to notice something. Sorry, okay? So let's suppose the pool is here, okay? So are we going to add liquid A? We're going to open faucets A and B. And when both are open, it takes 7 hours. I'll just note 7 hours. Here's some information that's super important for being able to solve it. Logically, look, it says, faucet B takes half the time that faucet A needs. Let's see what that implies. Well, it means that faucet B has twice the flow of faucet A, right? And why is that? It says faucet B alone takes half the time. Imagine, for example, that faucet A takes 10 hours to fill something. Then faucet B would only take half the time, that is, 5 hours. Why would it take just half the time? Well, this means that faucet B fills twice as fast as faucet A. We agree on that. That means then that faucet B has twice the water flow. Well, it has twice the water flow rate, right? Therefore, I could do the following. Look, imagine that we could divide it into 3. I'm going to divide it like this. I ask you, if we were to divide it into 3, and these parts were exactly the same, okay. But well, how many parts of my container are going to be filled because of the flow coming from the faucet? How many of those 3 parts? Well, just one, right? Let's suppose it's this one. How many will be filled due to the flow? Because of the water from faucet B, 2 will be filled. I'll change the color. This one and that one will be filled. Why is that? Since faucet B fills twice as fast as faucet A, we know it fills more in the same time. Do we agree? Great. Now with this info, it's really easy, right? Let's think about faucet A. I'll put it here, faucet A. Let's see, this faucet A is filling 1/3 of the total volume. I'm going to call it X. In how many hours? Well, in 7 hours it only filled 1/3, because the other one filled 2/3, right? I mean, double. So I ask myself, well, if this one here filled 1/3 of the total volume, faucet A, so how long will it take to fill it completely? Well, if it filled 1/3 in 7 hours, then how many hours will it take? Well, 21 hours, right? It takes 21 hours to fill it completely, and that's all we have to do. That's faucet A. The question asks how many hours it takes to fill. It's 21 hours. So, the correct answer would have to be, well, let me see if I have it right. It's number 16. Yes, that's the answer. It's simple, right? But let's see if someone says, no, I just don't get it. Logically, well then, let's look at a process. Look, to solve it like this. Using some little equations, and that's what we're going to do. Next, let me erase this first. I'll just leave the answer, because we're going to have to get exactly the same result. Let's say here that A takes X hours to fill it. I mean, to fill the pool. While B, how long does B take? Let's see. Start thinking. If A takes X hours, I'll write it here while you think about it. So start thinking, how long does B take? Let's see. A takes X hours. But we already know that. Oh, here it was. AB takes half the time. So how long will it take B to fill the pool? Just half of X. That's X over 2, right? Now please start thinking about the filling rates. Let's see. Let's first calculate A's rate. Let's suppose we're going to fill just one pool again. So to find the rate, I would divide 1 by the time, right? But the time is X for A, right? Look, I'm putting 1 pool over the time. How does that give me the rate? What would the rate for A be? Well, it's so many pools per hour, right? So many pools per hour. So, in this case, if I just want 1 pool, it would have to be 1 pool over X hours. Okay, so that it gives me units of pools per hour. Right? Now let's do the same, but for B. So let's calculate the speed of faucet B, that is, the filling speed. In this case, it would be 1, but between what? Between X? In the middle. So like this, by the extremes and means rule, the 2 multiplies the 1 to make 2, and the X goes below. We agree. Careful, this is the speed if we want to fill the pool only with A, and this would be the speed if we wanted to fill it only with B. Okay, but now I want a flow that is combined. I mean, not a flow, but rather a filling that is from both. Therefore, I would have to add the speed of A plus the speed of B, right? Because I want to fill the pool using both faucets. So I would have 1 over X plus 2 over X. And let's see, are we going to do this addition then? In this case, it's an addition of like fractions, since they have the same denominator. Therefore, we keep the denominator and simply add the numerators. 1 plus 2 is 3. This one is already correct. It's the combined speed, right? Now remember that we also have a value for the combined speed, even though they are not giving it to us directly. But we already know that it takes 7 hours to fill a pool. We agree. This is a speed after all. Right. A speed of filling one pool every 7 hours. All right. So this is the combined speed, because that's what the problem says. Therefore, we can set this equal to what? Well, to the combined speed that we just found, which is 3 over x, and that's it. So now we just need to solve for x, and that's it, right? This x is dividing, so it will go to multiplying. And this 7 is dividing, so it will go to multiplying. So I end up with x times 1, which is x, equals 3 times 7, which is 1. And as you can see, we're getting to the same answer. Obviously, this process is a little more complex. That's why I told you it was important to try to do it logically. I'll give you both solutions so you can choose. Now, let's move on to the next exercise, which says, the brothers Juan, Pedro, and Luis bought a house for which they paid 3 million pesos. Pedro contributed twice as much as Juan, and Luis contributed as much as Juan and Pedro together. What approximate percentage, note, approximate, of the cost of the house did Pedro pay? Let's see. Let's lay out everything that's there. So it says that among Juan, I'll use a J, Pedro, and Luis. So, the three of them bought a house for which they paid 3 million. So these three equal 3 million. Careful. J is what Juan paid. P is what Pedro paid, and L is what Luis paid. All right, that's what each letter there means. Then, it says Pedro contributed twice as much as Juan. So Pedro equals 2 times Juan, right? And then it says Luis contributed as much as Juan and Pedro together. So Luis, as much as Juan and Pedro together. So, in this case, we already have a system of 3 equations with 3 unknowns, right? 1, 2, and 3 equations, and the unknowns are J, P, and L. And they're asking us for the approximate percentage that Pedro paid, so we need to express everything in terms of P. All right, let's do it. Let's see. I'll solve some variables directly. For instance, Pedro is already isolated here. But we want to express J here in terms of P, so let me solve for J from here. This 2 would go to the denominator, so we get P over 2 is what J equals. Now we'll just substitute directly. Instead of writing J, we'll put P over 2 here. Let's see here. In this case, we almost have it, right? Because L equals J plus P. But we've already established that J is 1/2 of P. Or, well, P over 2, so I end up with P over 2, which is this J plus P. And let me go ahead and add these fractions. If we have P plus P over 2, that would be the same as 3/2 of P, right? Because it's 1 whole plus 1/2. Now we have 3/2 of P. J and L are both in terms of P now, so we can move on to this part. Therefore, I would have J, which is P/2 plus P, which is still P, and plus L, which is 3/2 of P. 3/2 of P. This equals 3 million, right? Let's see. 3, 4, 5, 6. There it is. Yes, it's 3 million. Aha, perfect. Now let's do the addition. Here we have 1/2 P, and here we have 1.5 P. So between this and this, that's a total of 2 P more. Sorry, I think I erased too much. Here it is. This is 2 P plus another P, so that's 3 P, right? Therefore, I'm going to continue down here. So I have that 3 P equals 3 million 1, 2, 3, 4, 5, 6. Since the 3 is multiplying, we divide by 3. So, 3 million divided by 3 equals 1 million. Pedro invested a total of 1 million, but the question isn't about the amount he contributed. It asks, what percentage of the house's cost did Pedro pay? Well, to find out the percentage, we just have to divide what Pedro put in, which was 1 million, by the cost of the house, which was 3 million. There it is, right? And multiply it by 100 and well, here we can cancel out 3 zeros, 3 zeros, 3 zeros, 3 zeros. And I'm left with 1/3 times. 100 1/3 is the same as 0.333, and so on forever, so it would be 0.333 times 100. This is going to give me 33, and now this is a good percentage. It's going to be 33. 33.3. But is it asking you for the approximate percentage? So option B is correct. Let me check first. Question 17. It says that the answer, I don't have it here. Here it is. Sorry. 17 is B. I put B. Correct. Good. That's it. Right. Done. That was easier since it was a system of equations. Let's just move on to exercise number 18. Don't forget that this video will go up to exercise number 22. We're almost there. Number 18 says, Diego can paint a house in 10 days, while Emilio takes 15 days. How many days? Sorry. In how many days will Diego and Emilio paint the house if they work together? Let's see here. Something that I think is very common to do is the following. Normally, people say, oh well, what I'm going to do is add 10 plus 15 and divide by 2. Okay, and that would be wrong, right? 10 plus 15 equals 25. Divided by 2 is 125. They say the correct answer is A, but that doesn't make sense. Why do I think that? Because if Diego alone takes 10 days and Emilio alone takes 15 days, how is it possible that together they would take that long? 12.5 days. That doesn't make sense, right? I mean, it couldn't be more than 10 days, because if Diego alone does it in 10 days, how could it take longer when someone is helping him? So, this would be wrong. So, the correct answer is definitely not A. Let's see. Could it be B? I mean, could it be that they only take 5 days? Well, no, that's not it either. Why is that? No, because if there were 2 Diegos, Diego and his identical twin who also takes 10 days, then yes, right? The answer would be 5 in that case, but since Emilio is slower, it's not 5. They also won't take half the time. So, the answer could be 6, it could be 7.5, or it could be 8. Those make more sense, because it really has to be more than 5, right? I mean, it has to be more than half of Diego, but less than 10, or less than what Diego alone takes. So, these values are within the range of possible solutions. So let's see. Let's go ahead and solve it. Look, I'm going to start by first calculating the speed at which Diego works. So let's call it Diego's speed. How would we do it? Simple. We just use one house. Divided by 10 days. That's Diego's working speed, right? He paints a house in 10 days. Now, let's see how fast Emilio works. He takes 15 days to paint a house. Now what? What is it? What we would have to do is add their 2 speeds together, right? So let's do it. So we put Diego's speed plus Emilio's speed. So we have 1/10 plus 1/15. There it is, right? Let's add them up. I'll use the butterfly method. Or actually, the least common multiple, since that's easier. Yes, because 30 is easy. The least common multiple of 10 and 15 is 30. Divided by 10 is 3 times. 1 is 3 plus 3, 0. Divided by 1/5 is 2 times 1 is 2. So I get 3 plus 2, which equals 5/30. We simplify by dividing by 5 and by 5, and this leaves me with 1/6. This is the combined speed, meaning what they can cover together, 1/6. So they paint a house. Sorry, let me see. My tablet got disconnected for a moment, I think. But there it is. It's ready. What does this speed mean? Well, this speed has units. Of what? Well, of houses. Why per day? What am I saying here? Well, I'm saying that between the two. Look, between the two. They paint a house every 6 days. So, in how many days will they paint the house? Diego and Emilio work together. Well, if they paint a house every 6 days, then the answer is 6, right? So will it take them 6 days to paint a house? Therefore, the correct answer should be option D. Sorry, C as in cat. Let me see what it says here. Exercise 18. It says the answer is C. So yes, we're good. That's it. That's all we have to do. Easy, right? All right, let's move on to the next exercise, number 19. It says, Considering the numerical sequence 0, 3, minus 6, minus 7, 3, 6, 9, minus 18. Okay, which of the following sequences follows the same rule as the previous one? Okay, let's see. I want to make a comment here. Look, this is actually wrong. It's not the rule. Here they really should have looked for another word, but not rule. When you talk about a rule for a sequence, are you really referring to a model? I mean, a mathematical model, for example, 2n plus 6. This rule gives me this sequence. 2x1, 2 plus 6, 8. 2x2, 4 plus 6, 10. So then 2 times 3 is 6 plus 6 is 12. So this rule gives me that sequence. Okay, and here they're asking you, which of the following sequences follows the same rule as the previous one? Let's see. They're actually different sequences. So strictly speaking, all the rules are different. All the rules are different. So, as it is, the question really couldn't be solved, because each of those sequences, being different sequences, has different rules. Therefore, the answer is none, as it is. But analyzing a little, what those who made this guide possibly meant is the following. Look, from here, do you realize that from 0 to 3, you have to add 3? Then from 3 to 6, well, we could think that we subtract 9, or that we multiply by minus 2. Okay, so let me put it better. I'll put it in parentheses so I can show I'm multiplying by minus 2, since 3 times minus 2 equals minus 6. See, that's repeated here. Minus 6 plus 3 equals minus 3, right? And then minus 3 times minus 2. Yes, I get plus 6. And then minus 6 plus 3. Finally, 9 times negative 2 equals negative 18. So, what this problem wants is for you to see which of these sequences behaves the same as this one. You need to do the same thing to get the next term, but that's not the rule. Remember, a rule is a mathematical model, and each should have a different rule. Why? Well, simply because they are different sequences, okay? I mean, there can't be two sequences that have the same rule. No, that's not possible. But some sequences behave the same way and follow the same pattern. Let's approach it the same way. Let's quickly identify the pattern here to see if it matches. I'll mark it in green. From 0 to minus 3, you'd think adding 3 works, but that's incorrect. So, this doesn't work. Why? Because 0 plus 3 doesn't give me minus 3. I mean, it should really be 0 minus 3 here. But it doesn't fit, so it's not that simple. Let's see, from minus 1 to 2, from minus 1 to 2. You have to add 3, From 2 to minus 4, Here it's fine. You have to multiply by minus 2. This one doesn't work from minus 4 to plus 8, right? Because from minus 4 to plus 8, adding 3 isn't enough. From minus 4 to plus 8, you add 12, right? So this isn't it either. Let's see if at least one is correct. Let's continue. From minus 5 to minus 2, you have to add 3. From minus 2 to 4, you have to multiply by 2. That's right. From 4 to 7, add 3. From 7 to minus 14. Multiply by minus 2, the pattern is plus 3 minus 2. Repeating, plus 3 times minus 2. Notice that this one follows the same pattern, so the correct answer would be as follows. Except that this part shouldn't be like that, right? It's important to mention that. The correct answer for number 19 was likely C. Yes, they did put, 19. Yes, you marked number 19 as C, so we got it right. Let's move on to exercise 20. It says, which of the following number associations has a different rule? Well, look, it's very similar to what I was just telling you. No, this really isn't the rule. Well, I mean, that's wrong. But anyway, we've already seen what it's referring to, so let's try to quickly figure out which one has a rule. I'll put different in quotes. Well, let's do some calculations. I'll start with the easy ones. For example, I add 4 to go from 0 to 4. Then, from 4 to 2, I either subtract or divide by 2. I add 4 to 4 to get 6. From 6 to 4, I subtract 2. This is clear, right? Now I'll take this one, also simple. From 2 to 6, I add 4. From 6 to 4, I subtract 2. From 4 to 8, I add 4. And from 8 to 6, I subtract 2c. They're the same. Plus 4, minus 2, plus 4, minus 2. So we've already seen that they have to be like this, right? Because only one should be different. Let's check this one. From -1 to 3, you add 4. Then from 3 to 1, you subtract 2. Then from 1 to 5, yes, you have to add 4. And from 5 to 3, yes, you have to subtract 2. Well, that's 3 after 2. Let's see. Let's go with the first one. From 5 to -1. From -5. Sorry, to -1. You have to add 4. From -1 to -3, you have to subtract 2. We're doing well. To go from -3 to 1, add 4. And from 1 to -1, yes, you have to add 2. Well, I found it at the end. It's going to be B. Let's check it quickly. Let me use a different color. To go from 1 to -3, subtract 4. So you just subtract 4. So this would have to be the answer, because it's asking you which one has a different rule. So it would have to be option B. Let's look at exercise 20 like this. If it's correct, then good. We only have 2 exercises left, which would be 21 and 22 of this first part. One moment, please. I ask that if you haven't subscribed to Mathematics with Grajeda, please do it right now, because otherwise you'll forget. And also turn on the notifications. Sorry, the notification bell, so you get the notifications, and that way you can also see the solutions to the other exercises. Remember, there are 60 in total. I think they only appear in this practice exam that the Universidad Autónoma Metropolitana provides for admission to higher education. In this case, for the Department of Basic Sciences and Engineering, or, well, for Basic Sciences and Engineering. I don't remember if that's the name of the department at that university. All right, let's continue. Number 21. Express the perimeter P of an equilateral triangle in terms of its height h. Okay, let's see. So we have an equilateral triangle, and we're going to draw the height. All right, I'm going to use another color. Let's draw it. This is the height, even if it's a little crooked, but you get the idea. This is the height. Let's say it is. In this case, we don't know how long each side is, right? So I'm going to say that each side is, well, this one is A, this one is A, and this one is A. That's it. And that's all the information we have. Just the perimeter, which would be equal to a plus A, so that's 3A. But it says that I don't want it expressed in terms of A, but rather in terms of H. In this case, there's no other way but to apply the Pythagorean theorem, because we can't use A. And the formula is base times height divided by 2, because if we have the base and the height, well, we don't use it because we don't have the area. So using the area formula doesn't really help me. What helps me is using the Pythagorean theorem. So in this case, I'm going to split my triangle like this. And as you can see, a right triangle has formed here. Focus only on the one I'm highlighting in green, okay? This one. In this case then, this is a leg. But since this is a height and it's an equilateral triangle, it splits it in half here. So, this leg is over 2, the other leg is h, and the hypotenuse is a. We have everything, right? So, come on, let's set up the Pythagorean theorem, which says that in every right triangle, the sum of the squares of the legs. Here, I'm already adding the squares of the legs, which is equal to the square of the hypotenuse. That's it, right? I already have my Pythagorean theorem set up. Now what I'm going to do is solve for a, why? Well, so that it's in terms of h, right? Let's see. Let's do it here. Let's square a over 2. So I get a squared, which would be a squared over 2 squared, which is 4 plus. H squared equals a squared, this a squared. I'm going to move the quarters to the other side. So I get that h squared equals a squared minus a squared over 4. Let's see. It's like if we had a 1 here, so it would be 1 a squared minus 1/4 of a squared, right? And that would give me 3/4 of a squared. Do we agree? So here I'm going to write that h squared equals 3/4 of what? Of a squared. Let me solve for a from here. So I'm going to move this 4 over here multiplying, and the 3 I'm going to move dividing. So it's going to be 4h squared divided by this 3, and that's going to be the same as a squared. And now, let's see. Here I'm going to take the square root on both sides. Okay, on the left side, we can calculate the root, right? Not all of it. The square root of 4 is 2. I'll just take it out now. The square root of 4 is 2, and the square root of h squared is h. So only 1/3 stays in here, right? So I'm going to write the square root of, let's see. Let me write it correctly. 1/3. Is it the same as the square root of a squared? Let's see. I'm going to say here that the square cancels with the root, but actually, it's not that it really cancels. The square root of a squared is actually the absolute value of a, but let me put it this way, just so I don't get too formal. The square root of a squared, let's just say it's a. All right, let's continue over here. So then we have 2h times the square root of 1/3, right? That's what I have over here, and now I can go to my perimeter formula. So now we have that p equals 3 times a, but we've already figured out a. That's 2h times the square root of 1/3. We can work with this now, can't we? 3 times 2 is 6, so I'd have 6h times the square root of 1/3. We already have p as a function of h, but honestly, I'm not sure. This means that we're wrong. It doesn't mean that we're getting to an expression that's equivalent, numerically speaking, or algebraically speaking in this case, since it has letters. We need to work with this expression to see if we can match one of these, though I'm not sure which yet. But let's continue. Something that comes to mind is that we can put this 6 back into the root again, okay? Earlier we removed a 2, even though there was a 4, and took it out as 2 now. After multiplying by 3, it turned into a 6, right? Now I'm going to put it in. I'm going to put this 6 in. So I have that p equals h. Because of the square root, don't forget, we put the 6 inside the root. But when we do that, it becomes 36. Not really, since 36 is 6. We're multiplying the squared value 36 by 1. So p equals h times the square root of 36 over 3. And that square root is pretty simple, right? So I would have h times the square root of 36 over 3. But 36 over 3 is 12. Now what we have here would already be the answer, but again, it's not quite there yet. Don't worry, we're almost there. So I end up with the perimeter equal to h. And here, notice that I can break down 12 as 4 times 3, so I would have h times the square root of 4 times 3. And now, this 4 has an exact square root, which is 2. So I end up with the square root of 4, which is 2 times h, and times the square root of 3. Let's leave that inside the square root. And that's it. That should be it. Now, right? Let's see. 2h square root of 3 2h square root of 3. Well, that's it, right? Let's see. 2 square root of 3h. Yes, it's the same, so that should be the answer to part A. Let's check. Exercise 2.1 is like this, right? That's it. If we did it right, that's what we should do. It got a bit more complicated, but as you can see, we're using some topics that I've already covered in previous videos. Let's see. Just to clarify a few things, and it's important to tell you this. Look, on my channel, I've already thoroughly explained how to work with, for example, perimeters and how to use the Pythagorean theorem. I also already have some videos where I've worked, for example, with roots, and in general with solving for variables. I've already done that. So if you say today, it's just that I don't really understand how he did this, for example. Don't worry. Down here in the video description, I'll put the videos of the topics that are needed to solve the exercises, okay? So, if for this exercise, for example, you need the Pythagorean theorem, just know that here in the description, I'll also put a link to the videos about the Pythagorean theorem, so that when you're studying this and you get stuck, you can go watch the videos, review the Pythagorean theorem first, and then come back, so it will be much clearer to you how, for example, exercise 21 was solved. I'll do the same for the rest, and include links about sequences and everything we've covered in these 10 exercises. When we do the next block, we'll work the same way, so that you have all of them explained. you can move on to bigger possibilities. But I appreciate it a little. That a merchant mixes Veracruz coffee, which costs about 130 pesos, I suppose, and economy, Chiapas coffee at 115 with Paneco coffee at 115, and he gets 100 kilograms, which he sells at 120.25 per kilogram. Okay, how many kilograms of Veracruz coffee did he use? This problem, as written, seems extremely difficult, and it might seem very similar to what we were looking at with painting the houses. And that's not, well, with Diego and Emilio, I think it was. But it's really not like that. I mean, this exercise is different. Here specifically, it's about a system of equations exercise. I'll solve it using a method. Probably the simplest, the addition-subtraction method. So I'll use that. Okay, for that. First, we're going to set up the two equations. When we talk about Veracruz coffee, we'll use a B. And when we talk about Chiapas coffee, we'll use a C. Okay, so it says, a merchant mixes Veracruz coffee at 130 per kilogram. Okay, with Chiapas coffee at 115 per kilogram and gets 100 kilograms, right? So let's set up an equation first for the mass. So for the mass, it would be, well, the weight of the Veracruz coffee plus the mass, well, not the mass. The weight plus the mass of the Chiapaneco coffee has to be equal to 100 kilograms, right? It's a blend, okay? The Veracruz coffee and Chiapaneco coffee together, total 100 kilograms. Next, let's set up an equation for cost. Veracruz coffee costs 100 or 130 per kilogram. Therefore, I'm going to put 130. For the kilos of Veracruz coffee we will represent. Remember, with the letter V plus Chiapas coffee costs 115 for the kilograms of Chiapas coffee we have. This needs to give me 100 kilograms for the price we're selling each kilogram for, right? So in this case, it's 120.25, which is how it would be for Veracruzano, right? That's it. We can work with this one now. Let me check. I'll make this 130. Or actually, I'll keep it at 115. And here, we multiply 100 by 120. 0.25 is just moving 12 decimals, correct? Sorry, is this how it should look? 12.025 is done. So let me erase the little equation that's here in the middle. Let's see. It's too big so that we only have our system of equations. There, nice and clean, which would be this one right here. That's the one we have to solve. And as for how to solve it, well, I think it's pretty simple. For example, I just want to know how many kilograms of Veracruz coffee I use. I mean, I want to know the value of V. So if I want to know the value of V, using the elimination method, I would have to eliminate C. And to be able to eliminate C, what do you think? What if we multiply the first equation by how much? Well, by 115, or by negative 115 if you want, but I'll just make it positive, so by 115. So here I would get 115 times V is 115V, plus 115 times C is 115C. This equals 115 times 100. So I write 115 and add 2 zeros. The second equation, let me move it up a little. Over here it was 130V plus 115C equals. Minus, the next equation was negative, and that takes it over there. Perfect. Add these velocities of est pasc, which I fill in ACU. Will you see the experts? And February, that's 12,025 minus 11,500. I'll reverse it, then we'll switch. We know the result will be negative, but I'll do the subtraction the other way. Remember, no calculator. I'll handle the subtraction. Here, 5 minus 0 is 5. 2 minus 0 is 2. This turns into 10. 3 minus 5 is not possible. So we borrow, it becomes 1. 3 minus 5, that's 8. And then 1 minus 1 is 0. I'm getting 525. But since I did the subtraction the other way around, the result would be negative 525, right? Since the negative is bigger here, it turned into a negative. Here, V is negative. 525 and this is negative 15. We're going to divide it. So I have to do the division of 525 by hand. Remember to divide by 15. Hopefully it's a whole number since there are decimals. We'll check how many times 15 fits into 52. Does 15 fit into 523? 33 times 15 is 45, and from 52, that's 7. And we bring down the 515 goes into 7. 5 times, right? Yes. 5 and 5 times 15 is 75, so 750. So I'm getting that the kilograms of Veracruz coffee are 35, right? That comes from doing this division, and that's it. 35 kilograms. There it is. So, the correct answer is yes. Let's check exercise 2222. Yes, that's perfect. So we're finishing this first part. I know the video ran long, but that's normal since it's important to explain things clearly. The other exercises, like I said, we'll do in the next video, from exercise number 23 to 32. And then we'll do another 10, and then another 10 after that. And we'll keep going like that until we finish all the exercises related to mathematical reasoning or math. Well, that's it for today. Please don't forget to subscribe to the channel so you don't miss the videos I'll be uploading, as well as all the other content I already have for you. Remember, it's free. See you next time. Take care. Bye.